and welcome to my Build a Bot workshop, where you will learn how not only to build a bot out of circuits, but also how to incorporate it into a really fun, engaging project with real world applications. I broke this project up into two different versions, grade 3 through 5 and 5 plus, grade 5 plus. The grade 5 plus really can literally go on through high school. Some of these concepts, I've worked with high school students that are interning with us this summer, and they actually did not know not only how to build the circuit, but they didn't understand why the bot was moving the way he was. So even your high school students will gain a lot of understanding of physics and electrical circuits from doing this project. So I broke it up into two different versions based on content that I think students would be engaged with at the different age groups. So for the group 3 through 5, here are some of the learning goals that will be covered by this project. So they're going to learn about physical science. They're going to learn about electricity and circuits, but also how mass and forces, including friction, affect the direction of their bot. In the 3 through 5 projects, I incorporated a project around life science and supporting endangered species. And you have an example of that in your workbook that you should have gotten with your project. If you didn't, you can, I'll be able to send that to you and you can download the little workbook, but it's really meant specifically for this project, not for your students. I have different content that you'll be able to download for your students directly. But in the 3 through 5 project, the students are basically going to transform their bot into an endangered species and design a nature preserve to help support that bot species. So we can focus on sustainable development goals, number 14 and 15, depending on how they decide to design their bot. And they're going to use some references to learn all about different endangered species. There's a lot of choice in here because the students will get to pick the species of their choice. Again, there's engineering, so how friction and mass can affect the bot design. And then we have ISTE standards. As your students are doing research, they can use their digital literacy skills, and we typically involve, we're very heavy into student presentations. So once your students finish their project, they can create a video presentation of their project and use a whole array of different video technology tools to make their project, their video production really unique and spectacular. And we include language arts through speaking and listening, through their presentation skills, through their research, and also through creative storytelling as well. For the grades 3 through 5, they're also going to learn about physical science, use the same ISTE standards for doing research and using technology for their production skills, and language arts. But the theme of the project is a little different for the older age group. So these students are going to consider their bot as a human with, as you'll see soon, every bot has its own natural tendencies. So the student's challenge will be to help the bot based on its specific tendencies to walk in a straight, or travel, I should say, in a straight line. So the students are going to be focusing on adaptive device design and engineering as a part of their project, and we incorporate a little race and competition at the end of this project as well. Whether you're doing the 3 through 5 or the 5 and up version of the project, we have facilitator guides, a student guide, and then we have engineering design process worksheets that your students can fill out, and depending on which group, different scoring sheets, so your students can assess their work on their own. Just a snapshot of the facilitator guide. I broke it down, starting with what is a bot and a discussion about what a bot actually is. We talk about the anatomy of a bot, and I have a link to video which shows all different ways that people can build bots. And then a project overview, which again will be different based on the group and the project that you're doing. And then a little bit more understanding the science behind what makes the bot move and move in different directions. So moving on to our Build a Bot project. If you have a mini maker kit, it's time to open it up and you can play along. If you're watching this video, after the fact, you'll be able to stop the video and kind of follow along with the images as you go. But it's basically a simple circuit. So here is a list of the materials, if you did not get a mini maker kit, that you're going to want for these projects. And I will move ahead because you can stop the video if you're watching this in not real time. Here's an example of the student guide. So there's a lot of detail in the student guide about what is electricity and how to make a circuit. If you're working with the younger students, you don't have to use you don't have to hand out this part of the student guide, but you can use this as your own guide to help direct the students as to a better understanding of what electricity is and how to create circuits. When you break open your kit, you're going to find a variety of materials, but I'm going to have you start with the motor. Now, the actual hardest part of building a bot is actually exposing the right amount of wire. So this is one area where your youngest students might need a little bit of help. You'll notice on your motor that there's only a very, very small amount of exposed wire, and you can build the bot without making more exposed wire, but they will be a little bit wonky and a little testy. So they may require like a little bit more pressure to get the bot to continuously vibrate and move. So it does work better when you remove a little bit more wire. For your younger students, what you can have them do, like in the image on the right, is use a not particularly sharp pair of scissors and just score the wire a little bit lower down on both the blue and on the red wire. And then use their fingers and pull the scored part of the wire off. If you have a wire cutter accessible, that definitely is a nice option as well. And how much wire they want to expose depends on the lithium battery that you're using. You just want the amount of wire to be about the same length as the diameter of the lithium battery so that the two wires don't actually cross over and touch each other, because that will make the bot not work. So once your students are able to expose a little bit more wire, then it's time to start setting up your bot. Now, of course, the eyeballs are optional. You don't need them. I use just a little piece of triangle, but your bots can literally be anything that you want. So here's an example of a triangle bot that you see in the images. But here's a typical bot that we more often use. But as you'll see soon, your students should be able to design their bot however they want. So you'll find in your kit double-faced sticky tape. So the first job is to attach the motor to the piece of cardboard or to the bot using the two-sided sticky tape. Part two is taking another piece of sticky tape, and you're going to stick it to the cardboard wherever you're going to want the battery to go. And then you're going to put one of the wires from the motor onto the other side of the sticky tape. In the picture to the right, after you've done that, you're going to put your battery on top of the sticky tape with the exposed component of the wire. So that is now one half of a circuit, or essentially considered an open circuit. If you were to touch the next wire, in this case, the blue wire to the other side of the battery, he would start vibrating. So how you're going to get the second wire to stick is by using another piece of two-sided tape, or you actually can really use only one-sided tape in this case, so you don't have to remove the adhesive from the other, the cover from the other side of the adhesive. And you're going to stick the second wire onto the sticky tape and then stick it to, in my case, the nose, but the battery of your little guy. And as soon as that happens, he'll start moving. So now is time, if you, yeah, if you if you're watching this in not real time, play around at this point with getting your bot to move. The sticky tape is not super adhesive, so you'll be able to take it on and off multiple times, so that the bots don't run out of power before they have a chance to do their projects to completion. Once they get their bots working, now is when we start to focus on how we can incorporate concepts like friction and forces of mass to get the bot to do different functions. So I'm going to play this video for you because I think it's easier to see it in action on a flat surface. The images on the left are part of the student pack. So your students will be able to read about and learn about how, different forces on their bot can affect the bot in different ways. But I'll share this video with you, which will help elucidate more.
Students will use the engineering design process as they try to design a motorized bot to go straight. In the process, they'll use a bunch of different physics concepts like Newton's first and second laws, as well as concepts of mass, physics, and forces to design their bot appropriately. While the project is designed for students to learn by doing, you can use this video for some tips on how to help support your students. One factor that will affect motion is the orientation of the motor attached. Here you can see the motor is facing down, and this particular project, the bot is going pretty much in circles. Then we put it at a 45-degree angle. And here you can see he is going straight, although not officially straight, he still straightens out a bit. Here we put the motor horizontal, and he again is sort of going straight, but not really sure where to go.
Just as an anecdote, the reason why the last bot didn't go very quickly is also because I changed the surface. It was a little bit more rough and bumpy. So the surface that your students use is going to be important in how fast the bot can move. So just to keep that in mind when your students are doing their races and their projects, if they want them to move faster, smoother materials will be helpful. And carry on with the video.
Your students can also work a little bit with different mass on different sides and a different center of gravity. So here it appears that the more mass on one side pretty much increases the friction on that side, and the bot will spin the opposite direction. And you can see this in a number of different examples with different amounts of weight on either side. You can also play around with different orientations, and using the horizontal format, students can actually play around with the connectors quite a bit, and that will significantly affect the direction that the bot goes. You can explain it sort of like a rudder on a boat. These students decided to exploit their bot's tendency to go to the right by designing their track to accommodate his needs. They also made him tiny, so he moves much faster. This group of students actually used the pipe cleaners in the kit to create arms to prevent their bot from his tendency to keep turning to the right. So here is a
So yeah, so that gives you an example of some different ways that you can adapt the bot, or your students can adapt their bot to perform different, not really functions, but go in different directions. And those are just a few examples, but part of the fun of the project is for your students to come up with their own ideas as to how to change the orientation of travel of their bot. So now is my clue to stop talking, and or if you're watching this in not real time, take a break and start to play with your bot and see if you can appreciate different ways to make your bot go different directions. You'll notice in the kit, I also included pipe cleaners. Pipe cleaners are a great way to get your bot to have more friction on one side. Our connectors work really well as well, but the pipe cleaners are another option, especially if you don't have our connectors. And one thing I can show you, hopefully you'll be able to see, is that the nice thing about Corruget is that there's a lot of space in the middle. So you can actually put the pipe cleaners inside the cardboard of the bot. And then this is obviously a really long piece of pipe cleaner, but you can cut the pipe cleaner shorter. And by having the pointy part of the pipe cleaner on the ground surface, that will actually affect the friction. Something else you'll notice in the project descriptions, the student guides, is I am very non-specific as to, or not very dogmatic about rules. So there's really a wide opportunity for students. So like they don't have to make their bot go straight. So if their bot can't go straight, then they can change the track to accommodate their bot's needs. They can also use the pipe cleaners as an arm to hold on to the walls of their track. So that way they can get their bot to go straight. And then we also include a straw. So some of your students might realize that by putting a straw really, really close to either side of their bot, it prevents the bot from actually being able to turn around. So it might make the bot go a little slower, but it would still make the bot go straight. So anything is fair game in the bot races projects. So that's your chance for your students to really explore their creativity and working around problems in unique ways. So I'm going to go over a little bit more detail about the different projects. These resources will all be able to be downloaded. In your booklet, I gave you an example of a student site map or site plan for their nature preserve. That's not meant to give the student assessment an example of what students would create. But for the third through fifth graders, the theme of the project is that your bots are going to be an endangered species. So your students, and I have a link to the World Wildlife Fund's website with all of the different, well, not all of them, but many different endangered species. So your students can have a chance to explore, learn about the different endangered species, and pick the bot that they are most passionate about. They're going to research that species, and they're going to understand what their needs are, what they need in their natural habitat in terms of shelter, water, food, and then also explore what are the risks to their particular species that they chose. What are the hazards that are making that animal an endangered species? We gave out little ID cards so your students can create a little ID, naming their animal, their genus and species, and then giving a little bit of information about their habitat and their physical description. And your students' project is going to basically be to design a map of a nature preserve that keeps their animals safe from harm. So they're going to create their map, which is going to be basically the landscape where their bot will travel. And the goal is to have one hazard to their animal and create a physical barrier that keeps their bot in the safe zone and outside of the danger zone. And then in the kits that we're going to be actually selling eventually, we include, I don't think I have them here, unfortunately, but oh, I do, timers. So your students have to keep their bot within the safe zone for a specified amount of time. And they will be scored based on how long their bot stays in the safe zone, as well as, they're going to be scored on multiple factors. So not only the success of their bot and their engineering design, but also their descriptions, their research, their presentation, and multiple other parameters for which they can be judged, including a classroom vote as well. So in the kits, you have the little animal card. You'll be able to download the student worksheet, which is a guide, the facilitator guide, and also the scoring card. For the grades 5 and up, we changed the theme a little bit. So the students will have an opportunity to also explore how different forces affect their bot. And then assuming that their bot will still have some type of natural tendency to go in a particular direction, their challenge will be to imagine that bot as a human with a particular challenge and to design or engineer a device to help their bot travel safely in a straight line as fast as possible. So your students will be able to design adaptive devices and test them out on their bot to see how they perform. And then they're actually going to be building a track for their bot and testing how long it takes their bot to travel in a straight line from one end of their track to the other. In the kit that we sell, we're going to have a ruler system so that every group's bot, the track is the exact same length. And again, the track can be curved, the track can be straight, the track can be, it does need to be flat. It shouldn't be on a ramp because that's kind of unfair. But in general, they can design the bot, the track however they want, as long as it is 10 units long. And they'll have a race day where all the different teams can compete and see which bot is able to travel the fastest. And I already showed you that video. So on the right, you can see a sample of a bot scoring sheet. And then we also have an area on the worksheet for reflections. So students can kind of do a postmortem, or hopefully not a postmortem of their bot, but of their project, and see how they could potentially be more successful with the second iteration. Of note, in the bot scoring sheet, we reward students or student teams that do multiple iterations to really hone in on the fact that getting it right the first time is not the goal here. The goal is it's the process. And it's not about how quickly and easily you get from A to B. It's about the process of getting there. So the more engineering design sheets and edits that the students fill out, the higher the score actually. So how can you use this project and integrate it into other cardboard construction projects? We have a wide range on our website of all different lesson plans and activities that can easily be used with cardboard and our connectors or cardboard and tape, but also can be used in conjunction with the spot projects as well. So here's another example of another lesson plan or project. that uses a similar, similar materials, obviously, but the students are creating, actually, I have in this image a flashlight, but the students can actually make a flashlight out of the LED light that you guys have in your kit. And then they're going to use the same ruler and the same pieces of cardboard and connectors to create a little mobile and a groundhog. And they're going to use that to explore the effects of light on shadows. So this would be a little bit of a younger student project, but it's a fun way to augment your bot project. Here's another version of learning circuits with LED lights as opposed to motors, where students build smart lighting solutions for their home. We integrate civics with Build a Landmark project, which is also another lesson plan that we have on the website. We have a business development and entrepreneurship project where students build a store and they learn how to market their store and how to calculate a business plan with profit and losses. Great math project. Here's a fun friction project that uses slopes as well. It's called Fun with Friction at the 3Ducks Winter Park. And I'll show you this video because it's kind of fast. But they're exploring slopes with, they made a little sled and they have bubble wrap facing up to depict fluffy snow. Then they put it upside down to depict packed snow. Then they use plain cardboard for dirt and they find he moves a little bit slower. And then they try their sled on grass and come to the conclusion that one should never try to sled on grass. The modern zoo is one of students' favorite projects. And this is actually a simple machines project. So every animal in our zoo, students, again, this blends really well with life science, and students have to research different animals. And then they have to redesign a zoo enclosure based on specific animal needs. So in the Bengal tiger exhibit, they have to create a tree with a slope that allows the tiger to come down. It's not actually, even though in the picture there's a tiger in the pulley, I think it's an elephant project that involves making a pulley system. And then they can learn levers and linkages and wedges with another animal, and then a wheel and axle. So this is a really fun project that uses life science, simple machines, and also it's sort of like a double design thinking challenge because the students have to design the animal's enclosure, thinking about the animal's well-being, but also the visitor user experience as well. So they have to really think about their zoo enclosure from two different perspectives, the visitors and the animal's perspective. We have a Busy Bee and Pollinator Pathway project, which involves coding or no-tech coding and game design, as well as learning about bees and pollinators. And I won't play this video because it's kind of long, but you'll be able to watch that if you have access to this PowerPoint. Then we have another project. This was elementary school from Costa Rica. They used it for designing a recycling management system for their town. The fifth graders did the recycling design project, and it was actually the kindergarteners that built the little city. This was a bilingual class in Costa Rica, so if you can appreciate, the houses are described in both English and Spanish, which is a great way to tie literacy to your builds as well. We also have a full curriculum called the Global Futures Design Lab, which is basically a way for students to build an entire sustainable and equitable community of the future. It ties in all different learning academic goals and is filled with 21st century skill building in a really fun, creative project that allows students to really explore their own community, appreciate the things that are awesome about their community, but also consider the things that they would want to improve or some of the challenges that they see in their community, and then design real solutions to real problems that they uncover through research. So it's a really awesome project for students, and it culminates with a student showcase where the students can create a formal presentation with creative writing or descriptive writing, with video, with photography, and create a full presentation that we can post on the 3Ducks website. Here is an example of some of the projects and products, I should say products, that are available to purchase if you're interested. The best product for this particular activity would be the Go Box Classroom Kit plus the Bot add-on kit, which I'm expecting to have available within the next 2 weeks for purchase. But if you want to pre-order, I'll be able to share in a follow-up email how you can pre-order those. And that is the conclusion of the workshop. If you are interested in learning more about other applications for cardboard construction, other resources that I have, or are interested in having me run this workshop with your teachers in your school, you can either use the link or the QR code to link to create an appointment with me, and I would love to chat with you. So thank you for watching this workshop. Hope it was helpful to you. Please share your bot projects with us. I love to share student content on our website. And thank you from Marcy, Ayana, and Ethan at 3Ducks Design.